And today's lesson is it's an introductory to network policy and how that network policy works. And then we've tailored this specific to GKE. And if you're a GKE user, I'll walk you through the steps to get Calico installed on your GKE cluster. And then I'll be going through an example application. For the example application that I showed today, you'll have access to the documentation as well as all of the files and manifests, so you'll be able to run this on your own right after we have our session today. So I have probably around 10 minutes worth of slides that introduce the concept of network policy, talk a little bit about network policy in Google, and then I'm just going to hop to the terminal and start to walk you through live implementation. That you'll be able to practice it again on your own after we speak today. I'm going to do my best to respond to the chats as they come in, but as you see, this is a little bit of a smaller group today, so feel free to unmute yourself and ask any questions, and I'm happy to help out. All right, so let's get started. So, what we've come here to talk about today is network policy, which is basically network security for cloud native applications, and that's the way that that's done. And this has really become a necessity over the past 8 to 10 years as the developers have started to focus on taking their monolithic applications and breaking them into microservices. And they do that for a variety of reasons. It's very good for the business. They're able to increase their velocity, release without as much downtime, and there's a lot of benefits to doing this. But what's happened is that fundamentally an application that's a monolith would be performing most of its work in memory. So you think of these components on the left-hand side, the UI and transactions and data access and analytics, as one large binary or set of binaries that are running on a system, and they're using function calls in order to get their work done. When you decompose those applications into microservices, what's different is that rather than getting their work done in memory, they're getting their work done over the network. And this has created a lot more interest in just networking in general for cloud native applications over the past several years. But it's also created the need for us to create new ways of securing this network. And basically, policy enforcement in the past had been done as what we call a perimeter firewall. So there's really one firewall that was supporting this application, and the application would, when it did access the network, it would get its RBAC and its, what was authorized to do through the firewall itself. And so that was a pretty good model. With the microservices, now since the communication is all occurring over the network, policy enforcement really has to come down to the level of each one of the microservices. And we'll talk about how to do that today. But this is fundamentally the reason why network policy exists. And if you attempt to use some of the traditional tools like a firewall, perimeter firewall, there's really two different things that can occur. One is if you do set up the perimeter, but you allow everything to talk east-west, you're not really doing much to protect the traffic. In the traditional application being deployed was probably in some kind of a zone-based architecture. So if you had something that was communicating with the untrusted web, the internet, then you probably would put that into its own isolated zone, and then you might have another workload that's connected to the databases, and that would be in a separate zone. And you wouldn't want traffic to traverse through those zones unless it was specifically whitelisted, and that's how things have worked. But when you have a Kubernetes cluster now, and some of these services are facing the internet, other services are communicating with the databases, but you leave everything wide open, you lose your security posture. And oftentimes what happens is that this isn't something that's well understood by the security teams, until kind of the last minute as you're trying to get out there to production, and not having better controls in place can slow things down. So I'm going to talk about Calico today. Project Calico is an open source project that Tigera, we invented this, and we're the primary maintainers for this. We release a couple of times a quarter. And it provides some very, very advanced networking capabilities that are often used, in a data center context. Today, we're talking about GKE. GKE does use its own networking, but Project Calico also provides network policy, and that's probably one of the things it's best known for. The team at Tigera have contributed upstream into Kubernetes. And so the network policy is a core construct within Kubernetes that our team has helped to develop the spec. And Calico is an implementation and also a superset of that. We've also contributed to some other projects like Istio and Envoy. We've been able to add certain capabilities in there that enable us to authenticate workloads, which is another security use case. Calico is a pretty safe option to go with. We're deployed literally anywhere that you want to run Kubernetes. So if you're using a managed Kubernetes provider, all of them on the market today, OEM and embed Calico. So if you're using network policy today, you're likely already using Calico. We're also built into many of the popular distros. So, Rancher or VMware PKS, or Anthos, and many others will actually package Calico. And one of the things that not many people are aware of is that Calico will also run on bare metal and cloud instances. So you can actually take other hosts that are not running Kubernetes. You can actually bring those under management, and you can apply the same security policies that I'll walk through today. So Calico today, just from reports that we get from cloud providers and from partners, we know of about 150,000 clusters that are running Calico today. And we're certain that there are quite a few more that we're not aware of. So let's talk about what network policy is and how that's different from the traditional firewall. So the traditional firewall, when you would implement that, is generally based on some identity, which is usually a network identity. We look at the IP address of a source and an IP address of a destination, and then we whitelist and enable that connection to occur. Now that is a problem for Kubernetes because the IP addresses, they do churn quite frequently within a Kubernetes cluster. And, so if you're going to have an unpredictable or ephemeral, as we call it, IP address, it's really hard to use those existing tools of firewall to secure that traffic. So what's different around network policy and Project Calico is that rather than being focused on IP addresses, we're actually focused on labels. So for any pod, you can apply a label such as role equals front end for a front end service, and you could create another label for another pod with role equals back end, and then you could actually say, hey, front end is allowed to talk to back end. And regardless of what those IP addresses are, regardless of how many copies of those pods that are running, the security rules are really based on these key value pairs. And that also provides you some flexibility when deploying new workloads, because all you do is you set the tags on those workloads for how you'd expect them to behave, and basically the rest of it's taken care of for you. Which kind of gets into the declarative part. So Kubernetes has a little bit of a different mindset around everything being declarative. So you go to Kubernetes and you say, here's how many pods I want to run, or here's how many replicas I want to set. So I want to run a daemon set. And Kubernetes just makes it happen. It removes all the complexity of what happens under the covers and just gives you exactly what you've asked for. And that's the same way that the network policies work as well. So generally what you would do is, as you're setting up and deploying any of your pods, you also would deploy alongside with that a network policy that would specify what other services that pod is allowed to talk to. And this is built really for dynamic environments. So as these pods are being set up and destroyed and rescheduled on different nodes and scaled, this label-based declarative methodology of doing security it just works. You don't really have to go do anything or change anything. It will scale with your growth, and it will deal with that churn very, very well. And this is what Calico does. This is actually all of what network policy does. Calico implements network policy. It also has a superset that provides some additional capabilities, and I'll talk through those in just a moment. So one of the things that will occur at some point in time is that you'll have a discussion with the network security team about Kubernetes and about how you're going to deploy to production, and around how that team needs security to be implemented and what that architecture looks like. And when you get to that point, one of the powerful ways that you can position your Kubernetes deployment is as a zero trust network. Zero trust is a very popular term right now. It's a bit of a buzzword in the security community. There are many security organizations that have this currently on their roadmap, and it's a bit of an aspirational thing to get to. And zero trust oftentimes, usually where it's first implemented, is with your real users, your heartbeat users, as we call them. They're using mobile phones and laptops, and they're accessing systems from different locations. And zero trust was initially created for those use cases. But for zero trust for Kubernetes, what we talk about is the actual infrastructure to infrastructure connections. So not about the end users, but your workloads would authenticate themselves, and your workloads would grant trust first before they're allowed to do anything. So we'll talk through this, but a great way for you to position to your security team and to kind of educate and to get over this hurdle that you're likely to experience is to position this as, hey, this is a very strong security posture. This is a zero trust network that we've implemented. So what is a zero trust network? Well, the first is it's declarative, and this is our security architecture being deployed as code. And so, that can actually be shared with the security teams. They can see what that is. We deploy that as code. But one of the important aspects of it being declarative is that we're actually whitelisting connections. So when you roll out an initial Kubernetes cluster that doesn't have any network policy in it, every pod can talk to any pod, right? And even across namespaces, there are no limitations to where they can really communicate. But as soon as you've implemented a network policy and attached it to a workload, that workload moves into a default deny mode, meaning it's going to deny any connection that you haven't specified. So now we get into this aspect of whitelisting only the connections that are allowed, which is very similar to, with a firewall, what they'd be attempting to do with those IP addresses. And the next thing is that, what it's doing is it's because of the dynamic nature of the environment that's underneath, these workloads, we need a way to establish identity. And the concept here is that we have to establish trust with one of these workloads to know that the workload is what it in fact says it is, and it's not potentially some kind of a bad actor, something like that might have been fired up. And so what Calico does is it actually gets that identity from the platform. So it'll get the network identity from Kubernetes and certify that. If you've deployed with Envoy, then it will actually also use a second form. It's like multi-factor authentication. It'll look at an X509 certificate as well as a network identity. So you get multi-factor auth now, which is quite powerful for workload-to-workload traffic. And then we perform defense in depth. And what this means is that zero trust, it assumes that something in your infrastructure is compromised. And so we say we really can't trust the infrastructure, the application, something's been compromised. And as part of that, what we do is we evaluate and allow or deny traffic based on multiple points of enforcement. So this is actually at the pod layer, like a little micro firewall around the pod, but it's also in the host that's, or the node host that's actually running the pods. And so this gets us a really strong security posture. And the other thing is, if you're interested in not just kind of the infrastructure level rules, if you want to go up to layer 7 and actually specify security policies based on what REST API endpoints and methods, web methods are allowed, you can also implement layer 7 rules through an integration with Envoy with Calico, which is quite unique because most network policy is really based on layer 3 network traffic. So what is a network policy? Let's take a look at an example, and I'll go through some live ones here as well. But in this example, what we've done is these boxes, they represent pods. And we have a front-end pod. Well, we attached a role. So the role is the label, and then the value here is front-end. So we have a front-end pod, a database pod, and this one called helper. Now, what the policy does here is we have what's called a pod selector. And what we did is we matched on the label where role equals DB. Okay, so that attaches the policy to this blue role equals DB. And then we have an ingress rule. And the ingress rule is saying any traffic coming in from the pod selector front end, this is front end, we're going to allow, and it's going to be TCP port 6379. So that connection would be allowed. Now, because we haven't explicitly allowed an ingress from role equals helper, these connections would be denied every time they were attempted. And so this is the concept of establishing the least privileges within the security posture. So a little bit, so let me show you what's different about the Calico policy. This is the basic Kubernetes network policy model. Calico implements this, but it adds a few things that are really quite convenient. First is an order. And so using an order, you can specify that, hey, my policies will evaluate traffic before perhaps another team's policies or an end user's policies. And so a higher order policy that you might have is, hey, DMZ. So let's say we have a namespace that we call DMZ and a namespace we call it trusted and a namespace that we call backend. You can say, DMZ traffic is not allowed to talk to backend traffic. And no one could override that rule because you would have a higher precedent order in here. And there's a couple of different ways to actually enforce that as well. So the other thing that we have is specific actions. So we've specified a deny here. And one of the key elements is this capability of not just using pod labels, but to actually use service accounts. Why would you want to do that? Well, the pod spec itself doesn't really have an RBAC in there. So anyone can really put any labels that they want within the pod spec. But service accounts in Kubernetes are RBACed objects. So you can now implement RBAC, and then this enables you to define your rules that other people cannot go change. And finally, the selectors are much more flexible. And so in this scenario here, what we've actually implemented is some Boolean logic. And so what we would say is basically for this helper over here, we're going to allow anything with role equals DB or stage equals dev. And so that's more advanced logic that you can include in here. And then finally, we have this capability of including HTTP methods as well. If you choose to deploy our application layer policy, which requires integration with Envoy. What this would do is it says, hey, this can do a post to this exact path, table/star, which is probably some kind of an identifier, and then customers. So we get the wildcard in there as well, but then this would actually explicitly not allow things like a put. And ultimately, what you're doing with this is you're implementing your entire security architecture as code, and this can be integrated right into a CI/CD toolchain. So it aligns quite well with the DevSecOps movement. If you go out there and look at really any of the job descriptions for DevOps nowadays, security is a pretty important element, and this is a way that security can be automated and enforced. All right, so final thing is just about these micro firewalls. So within GCP, within GKE, what you end up having is this micro firewall in front of each pod, but then you also get it at the host layer. And so this is that defense in depth that I spoke about. This also enables you to run security on host endpoints where they're running no pods at all. So you can actually take this very dynamic policy language and you can apply it to cloud metadata within the environment to create rules and policies that way too. So this is the last slide. I'll get into the demo. There's a couple slides that show what the demo is going to be, and then I'll get into the terminal. But there's a lot on here, but the summary here is that the traditional network security approach using things like firewalls is just not a very natural thing for Kubernetes. It doesn't really work. It takes a lot of resources in order to get that to work. With Calico, it's just a much more natural Kubernetes native way of implementing network security. And the important thing is just to educate the network security folks in terms of what this is and why it's a better stance. All right, so let's get into the demo. What I'm going to do is I'm going to show you my GKE cluster and then where the documentation is online, so you can find it for yourself and how to do this. It's as simple as just Googling Calico GKE, and you're going to find this docs page. And so, this is how it works. So this is on Google's website, and they give you some instructions on actually how to implement this. I took the noob approach here, and I actually just used the GUI. But when provisioning a cluster, what you want to do is go to networking here on the left-hand side, and you want to enable network policy, this one right here. It has a little bit of information in here about Project Calico, and you can click on that to kind of go out there and look at our open source site and see the docs. But when you provision, you're going to want to select this enable network policy. You can add it later after the fact to an existing cluster, but it is going to drain all the nodes and move all your pods when you do that. And it'll give you warnings before you go through that upgrade. So the cluster that I have here is this demo cluster, and it's got 3 nodes that are running. And I should be able to, I think I've got kubectl configured here. All right, so you see my 3 nodes. And I can do kubectl get pods. And it's got some of the typical services that you would expect to see up here, but you also notice that it's running this Calico node here. It's going to be running Calico 1 pod per node, and so it's deployed as a daemon set. And that's the deployment methodology for Calico. Some folks ask also if it's running as a sidecar. It's not running as a sidecar. It's actually running as its own pod, which is running in the host. All right, so let's walk through a simple example. This is the demo that I'm going to show is an application that has a couple different namespaces in here. The first is we have a client. Now this is the web GUI, and it's in its own namespace called client. And you could think of this as perhaps a namespace that's going to run all of our internet-facing workloads. And then we have a front end where the business logic is running and a back end with data. And this is part of the actual application, which is called Stars. And Stars is a visual application that you'll be able to use and actually see the visual impact of your policies as you create them. And then we have a management UI. So this is a service that's basically pinging all these other pods, and then it's visually showing us what connection is allowed and which connections are being denied. So the use case that we want to prevent against is some form of a bad actor coming in, getting access to this actual pod client, and then directly accessing the back end. And we want to make sure that this is something which is not allowed, it's blocked, so that this potential bad actor would not be successful. And we're going to do that using our policies here. So if you just do Google search for Calico and Stars, you'll find the first link up here. And this is for the demo that I'm going to walk through today. And so after we do this today, everyone who's on the Zoom should be able to do this on your own. And if anyone ever gets stuck with anything, just feel free to drop me a line or anybody at the Tigera team, and we're happy to help out. And so what I'm going to do is I'm going to create the front end, back end, and management UI apps. I'll actually show you really quick what those look like. All right, so this is the application itself. We have a backend, and the way that this works is this is basically a container, and we just feed in some inputs here on services that it's going to probe. And so for this one, for backend, what it's doing is it's going to attempt to connect to the front end, the back end, and the client. And it's going to hit each one of those applications. Likewise, the front end is going to be connecting to the front end, the back end, and the client, and then the client likewise as well. And then we have the management UI app, which is going to be monitoring everything that's going on in the cluster. So this is what I'm going to deploy. And you can get access to all these files right up here. But I'm just going to go ahead and copy these, and I'll just paste them in right now. So if I do I can see that it's creating containers for my backend front-end management UI app. And there it is, our client as well. Okay, so it looks like things are up and running now. And then the next thing that I would want to do is connect up to this node port that's running. Rather than opening up all the access to my cluster, what I have is I have a port forwarding command. So it's just a basic simple command that's going to port forward this so that I can access it from my local system. And so I'll just execute that. Okay, and I should be able to connect to localhost 9001. HTTP. All right. So this is the application that we just deployed, and this is called Stars. So let me just spend a moment talking through what this is doing. But what we have is we have a C for the client, we have a B for the back end, and F for front end. And these connections that you can see are the attemptions, the connections that are being attempted. And the little white dots that you see that are flowing through them are the actual packets being transferred through. So these connections are actually being accepted. And what I'm going to do is I'm going to start walking through a couple of different examples of starting to lock this environment down. First, I'll completely lock it down, and then I'll start to whitelist certain connections. And so the first thing we want to do is enable isolation. And so these couple of commands up here are going to do that. I'll see if I've downloaded those up here. Basically, this is just going to match to everything, and then it's also not going to have any connections that are allowed. So once I deploy this, it's basically going to take down connectivity within the cluster. So let's go ahead and do that. Okay, so we deployed both, and what I should see is a pretty tough time up here when I refresh. Yeah, so it didn't want to be reachable here, but you notice it's I can't see any of those pods anymore. It's just a blank screen. So the next thing we want to do is we want to give at least the UI access to those services. And so I'm going to apply these, which are going to allow the UI, the management UI, to show me at least the pods and what they're attempting to do. Refresh, and there we go. So now the UI is able to see the client, the back end, and the front end, and you can see the lines. These are connections that are being attempted, but what you don't see is the traffic actually flowing through right now, because that traffic is all being denied because we haven't explicitly whitelisted those connections. And that's what we're going to do next, is we're going to create a backend policy that allows the front end to talk to the back end. And that looks about like this. What we're going to do is say we're going to attach to back end. We're going to allow ingress from front end. Okay, so just go ahead and execute that command here. All right, so now you see the back end is allowing these connections to come in from the front end. The final step now is to expose the front end to the client. Likewise, the front end policy connects to front end. It's allowing connections from the client. Just a moment. There we go. The UI, and this can be a little bit slow, but there you have it. Now the client is allowed to connect to the front end, which is allowed to connect to the back end. But that connection from the client to the back end that we wanted to make sure that couldn't happen, you know, that those connections are not, they're all being denied. So there's some additional code up here you could execute that basically just deletes the client, starts the management UI namespaces, and so the application goes away. You can clean up your cluster. But I invite you to do this on your own and give it a try. And there's several different things. You can start with this example, but you could also implement things like a zone-based architecture, where you might define what traffic is allowed to traverse between zones and ensure that no other traffic is allowed to traverse between zones. You could keep the traffic quite open within zones, but then only allow that to traverse. And it really is all about aligning with what your security team's network architecture is, and then implementing that here in Kubernetes. So just kind of some key takeaways here is that, network policy is really the way to do this within Kubernetes. Anything else is quite unnatural. And, Calico is a superset of Kubernetes policy. So there's quite a few more capabilities that we offer. This is offered out of the box by GKE. You can go into the management interface, or you can put this into your manifest when you deploy a cluster. And we've been proven at very, very large scale. And so there's several, very well-known platforms that are running out there, streaming the videos that we watch, doing a lot of the analytics that are supporting large enterprises that are all running massive deployments on top of Calico, and it's quite a scalable option. So I'm just going to pause there, and what I would like to share is if policy is something that you're interested in, that you'd like to get started with, one great way is to experiment with Calico Enterprise. It's an enterprise version of Project Calico, and it's going to get you things like a GUI that can help when you're implementing these manifests. It also will it'll watch the network traffic and auto create your policies for you. We've got ways that it can run policies in a permissive mode, so that it won't actually enforce or deny all your traffic, but it'll tell you where it was going to do that. And it provides additional deeper security requirements that typically you need as you get towards broader scale in production. And that's available for anyone to try out for free at tigera.io/trial. I know this slide is a little bit formatted bad. And I'd invite anyone that wants to give that a try to sign up.